Number 6, okay, integration of sec 1 minus z tan 1 minus z dz, but this one I think we can directly see from the trigonometry identities integration, where directly we will get integration of sec tan is sec. Okay, so this one is the direct solution. I think we will get sec 1 minus z plus c. Okay, alright, let's move to question number 7. So we want to substitute our u. We want to use the substitution u equal to 60 negative 1 plus t square. Therefore, we will have du over dt is equal to negative 60 to the power of negative 2 plus 2t. Okay, if I factorize out 2, negative 2, because if you see here, t negative 1 have constant positive. Okay, t negative 2 has constant positive. Therefore, I factor out the sign negative 2, so what I left in the bracket is 3 to the power of 3t to the power of negative 2 minus with t. Okay, du over dt. Okay, let's bring negative 2 to the left and dt to the right. Therefore, we will have du over negative 2 equal to 3t negative 2 minus t dt. Okay, this a little bit tricky. If you see in this integral, we have 15t negative 2 minus 5t, but here we only have 3t negative 2 minus t. Okay, therefore we actually need another 5 in front here, but we cannot simply add 5 here because it will change the original value, but we can divide this 5 by 5. Okay, because 5 over 5 is actually 1, therefore there is no changes happen in this equation. Okay, so you can bring this 5 in denominator to the left. So what you have on your left is negative 5 over 2 du. Now you have on the right 5 times 3 is 15t to the power of negative 2 minus 5t dt. Okay, so let's rearrange our integral. So I want to write our integral as the integration of cos 60 to the power of negative 1 plus t square times with 15t to the power of negative 2 minus 5t dt. Okay, so we decide before to substitute our 60 to the power of negative 1 plus t square with u, and if you see here, you have 15 t to the power of negative 2 minus 5t dt is equal to negative 5 over 2 du. So let's do the substitution. So we have here cos u times with negative 5 over 2 du. Okay, negative 5 over 2 can be written out of the integral. So we have negative 5 over 2 integral cos u du. So now we can integrate as usual. So we have negative 5 over 2. Okay, integrate cos, you will have sine. Therefore, we have sine u plus c. And don't forget to substitute back your u. So you will have the answer is sine 60 to the power of negative 1 plus with t to the power of 2 plus c. So this one is the final solution. Number 8. Okay, we have integration of 7y minus 2y to the power of 3 exponent y to the power of 4 minus 7y squared dy. So let's choose our u as y to the power of 4 minus 7y to the power of 2. Okay, so now we will have our du over dy equal to 4y to the power of 3 minus 14y. Okay, so if you see, your y to the power of 3 here has constant negative, but we have positive here. So let's factorize the negative outside the bracket. So we have, let's factorize negative 2. So we have here negative 2 y to the power of 3 plus with 7y. Okay, so this one is our du over dy. Therefore, we will have our du over negative 2 equal to negative 2y to the power of 3 plus 7y dy. right? So let's arrange our integrals. So we will have the integration of exponent y to the power of 4 minus 7y to the power of 2 times with 7y minus 2y to the power of 3 dy. Okay, and we want to change, or we want to substitute our y to the power of 4 minus 7y square here with u, and along this derivation you can see that negative 2y cubed plus 7y dy, okay, negative 2y cubed plus 7y dy is actually du over negative 2. Therefore, let's do a substitution. So we will have the integration of exponent u du over negative 2. And as before, negative 1 over 2 is just a constant that we can bring it out from the integrals. Therefore, you will have the integration of 1 over 2 out here. So the integration of eu du. So here the solution is negative 1 over 2, and you have the integration of eu is eu plus c. Okay, so now you can substitute back your u. Therefore, your final solution will be negative 1 over 2 exponent y to the power of 4 minus 7y to the power of 2 plus c. So this one is your solution. 9, we have to integrate 4w plus 3 over 4w square plus 6w minus 1 dw. Okay, now let's choose the one in denominator as our u. Therefore, we have u equal to 4w square plus 6w minus 1. So differentiate w with respect differentiate u with respect to w, we will have 8w plus with 6. Okay, now let's factorize out 2. From here you will get du over dw equal to 2 4w plus 3. Therefore, from here you will get du over 2 equal to 4w plus 3 dw. Okay, let's rewrite our integrals here. We can write our integrals like this: 1 over 4w to the power of 2 plus 6w minus 1 times with 4w plus 3 dw. This is the same thing as in the questions. Okay, and we decide that we want to substitute 4w square plus 6y minus 1 equal to u, and along the derivation here we can see that 4w plus 3 dw is actually du over 2. So let's substitute. What we will have here is the integration of 1 over u times with du over 2. Okay, so 1 over 2 is only a constant that we can bring out of the integrals. Therefore, we have 1 over 2 integrate 1 over u du. And this one is the reciprocal function, where when we integrate reciprocal function, you will directly get ln. Okay, so we have here 1 over 2 ln u plus c as your solution. Okay, and substitute back what is the value of u. You will have ln 4w square plus 6w minus 1 plus c. Okay guys, so now we see the last question number 10. Okay, you need to integrate in the bracket cos 3t minus t to the power of 2 times with sine 3t minus t to the power of 3 power of 5 dt. Okay, so if you see here, you have inner function, where the inner function is sine 3t minus t to the power of 3. So this one is inner function. Okay, so we will let our u equal to our inner function. Therefore, we have u equal to sine 3t minus t to the power of 3. We will have du over dt equal to, differentiate sign is cos 3t times with 3 plus with 3t square. Therefore, you will have du over dt equal to 3 cos 3t plus with 3t to the power of 2. If I want to factorize 3 out, so I will have du over dt equal to 3. In bracket, you will have cos 3t plus t to the power of 2. Therefore, you can write du over 3 is equal to cos 3t plus t square dt. Okay, so let's rearrange our integrals here. You will have the integration of sine 3t minus t cubed to the power of 5 times with cos 3t minus t square dt. Okay, we decide to substitute our sine 3t minus t to the power of 3 with u, and we can say that cos 3t plus t square dt is actually du over 3. Therefore, let's do the substitution. Okay, so you will have your integrals as the integration of u to the power of 5 times with du over 3. So 1 over 3 is a constant as before, so let's put it outside of the integral. So we have 1 over 3. Okay, the integration of u to the power of 5 du. Okay, so what you will have is 1 over 3 times with u to the power of 6 over 6 plus c. Okay, therefore substitute back what is your u. You will have your u is equal to sine 3t minus t cubed. So you have sine 3t minus t cubed to the power of 6 over with 6 plus c. So this one is your solution.